things, oh, thank you. There's two things I need to accomplish today. Number one, I need to give closure on Taylor's theorem, closure on making sure you guys can create a Taylor or a Maclaurin polynomial, and then that you can get the maximum possible error. Yes?
What's the difference between the Taylor series and the Maclaurin series?
I don't, someone tell me, what's the difference? Yes, Andrew?
Maclaurin is centered around 0, and then Taylor is just modeling around C.
Yeah.
C can be anything.
Exactly, where C can be anything. Because what happened is, I guess this dude Maclaurin thought of his series first, and then Taylor said, well, you can have it centered anywhere. And so we still want to honor this Maclaurin guy? I don't know. Okay, so anyway, I need to make sure you can make these series, and then you can get your maximum possible error. So here comes a couple, at least one final example. Let me get my, sorry, I got to get my notes, make sure I'm giving it to you in the right order. Okay, here we go. Suppose f of x equals the log natural of 1 plus x, okay? I'd like you to get the second order approximation centered at 0. I want to remind you, that means you're going to have to get what f of x is, what f prime of x is, and what f double prime of x is. And then you're going to have to get what f of 0, f prime of 0, and f double prime of 0 are. And then you're going to have to plug in to this formula. F of x is approximately equal to f of c plus f prime of c times x minus c plus f double prime of c over 2 factorial times x minus c squared. Now, of course, your c is 0, so it's going to look a lot simpler than that. So please do that now. Good luck. And I'm going to walk around, and if anyone says, Mr. Shana, I'm still clueless, I will help you. I will intervene. If anyone's stuck, step 1 is you've got to get these guys. Step 2, get these guys. Step 3, plug into this.
I think it's just 1 over 1.
No, I know that. Oh, sorry.
It's 1 over 1.
Okay.
Looking good.
Well, I just do 1 plus x, then maybe 1, and then I just do it again. So much easier.
We got a lot of quick hits.
You'll have my charger.
I do?
Okay. We'll go through it. Some of you might do that, but don't worry.
That's
You're in the SAT. You're in the SAT thing. When I need to go to your later.
Oh.
Yeah, you're fine.
Oh, but I left it on my patio. Yeah, you did it back when you at
You can't do that. If it was 1 plus x over x,
No, I had to
yeah, you can't. Yeah, 2
Are
over
you
5
sure?
isn't the same as 2 over 2 plus 2 over 3.
Yeah.
It
Eric, if you lost it, are you gonna buy me a new one?
Is that your answer?
Where's
Well,
your
yeah,
answer?
you can buy yours too.
Oh, you haven't, okay. Remember, you see a
No,
zero.
it has to be one. I did leave it outside.
Also, yeah, 1 over 1 plus x is not the same as 1 plus 1 over x.
I don't know. Sorry.
I've got several people who think 1 over 1 plus x is the same as 1 plus 1 over x. That's not true. You can't split the denominator. You can't say that, here, you can't say that 2 over 5 is the same as 2 over 2 plus 2 over 3, right? That's not true. So don't be splitting the denominator. You're just stuck with 1 over 1 plus x. That's it. That's what it is. Just like your lives. Just like your horrible lives. You're stuck with them. Okay, I'm going to have to do this now. F of x is the log natural of 1 plus x. F prime of x is 1 over 1 plus x. F double prime of x is negative 1 over 1 plus x quantity squared. So now I'm going to stick 0 into all of these, and I get 0, 1, and negative 1. And so I get f of x is approximately equal to 0 plus x minus x over 2 factorial. How many people got that answer? Okay, many of you. That's good. Is there any question or problem on this? Yes? Oops. Oh my God. Thank you very much. X squared. I want the video audience to know I've been screwing up just all morning, so this is no different than what I've been doing. Any questions or problems on this? Okay, then here comes the next part. Find me the maximum possible error in approximating f of 1.2 with my second order approximation. Get maximum possible error in approximation of f of, do I want 1.2? No, f of 0.2. F of 0.2. Please do that now. What's the maximum possible error in that approximation? And I'll even give you the hint. You got to get n, you got to get c, you got to get x, and then you got to get the maximum possible value of the third derivative of z. And in this case, z is going to be between 0 and x. Where this, c and x. Good luck. And then you'll plug into this. If anyone's still clueless, please call me over. Because this is it. This is our big
So I'm not clueless.
closure thing.
Did you get the answer?
2.
Just stupid.
Right on.
I'm still writing it down.
Me too.
So is everybody aware that you're going to have to get the third derivative now? By now, I'm gonna have to go through this. By now, I'm hoping you've identified your n as 2, because this is a second order approximation. Your c is 0, because it's centered at 0. Your x is 0.2, because they tell you you're getting the maximum possible error in f of 0.2. And then the maximum value of this guy, well, I'm either going to plug 0 in for x or 0.2 in for x. You tell me, what's the maximum value of the third derivative?
2.
Yeah, 2. Because if I stick in a 0, this guy's 2. If I stick in 0.2, this guy's going to be less than 2, because the denominator is greater than 1. So the maximum possible value of the third derivative is 2. So now I can plug in the maximum possible, the maximum possible error in the second degree approximation with 0.2 plugged in is going to be 2 over 3 factorial times 0.2 minus 0 to the third power. And it's that easy, you know. What do you guys get for that?
1 over 375.
1 over 375, okay. Did anyone express that as a decimal?
2.67 times 10 to the negative third.
2.67 times 10 to the negative third. How many people got that answer? Okay, many of you, that's good, you know. Any question or problem on this? Erica, question? You're good? You're good, Kenneth? You are not, you lie. Okay, then, hey, there's one more type of problem like this that I've got to give you. It's the type of problem that the AP exam people love. Because a lot of times, they don't want you to do this. A lot of times, they just come right out and tell you that. They just tell you, hey, the maximum value in the fourth derivative is boop. And then all you have to do is plug that in. And I love it when the AP exam does that, you know. Here, let me show you what I'm talking about, okay? I've got a function. I don't know what it is, but I have a second order approximation of that function. There it is. That's the second order approximation of that function. Find the maximum value of x that you can plug in find the maximum value of x that you can plug in so that the error is less than or equal to 0.001 given that the maximum value of the third derivative of x is equal to 3. So you guys are just plugging into this, except you don't have to find the maximum value of the third derivative. They just came right out and told you. And you don't know what x is, but you know what the error is. So you should be plugging into that. They've told you what the maximum possible error is, so you just need your thing to be less than or equal to that. Oh my gosh. Spent too much time on my homework. How many people are getting 0.126? Okay, hey, that's all there is to it. That's all there is to this problem. Any question or problem on this? Yes?
Why on the homework was it from negative and to positive?
Because they didn't ask for just the maximum value of x. They said, what is the range of x's you can plug in? So it's kind of different.
Okay.
Whereas on the AP exam, ordinarily, they just ask for the maximum value of x, so you only have to consider the positive guy.
Okay, thank you.
No, it's a great question. Yes?
If you put the absolute value of x is less than or equal to 1.26, they'll understand that those are the bounds.
Right, right. And because, because it's a third power, it'll be symmetrical. Okay, hey, here's the last one. In 4 minutes, our last 4 minutes, first order Taylor is the same as linearization. So whenever someone asks for a linearization, up till now, how did you always find the linearization? By finding the slope of the derivative, so you get the slope, and what else? I mean, what is a linearization? Did someone say tangent line? Yeah, thank you. It's the tangent line. Linearization is the equation of the tangent line. But I'm here to tell you right now, there's another way to find the linearization, and that's just by getting the first order Taylor approximation. They mean the same thing. And I'm going to demonstrate why. And then on tonight's homework, they're going to give you a bunch of problems where they ask for the linearization. I just want you to be aware, when they're asking for the linearization, what they're actually asking for is the first order Taylor approximation. Let me show you why. Here's the first order. Here's the first order Taylor approximation, correct? Thank you for saying yes. Here's the equation of the tangent line. Right? That I always advocate that you guys plug into the point slope form. So there's the equation of the tangent line. But look at the equation of the tangent line. What's my m going to be equal to? F prime of c, right? I mean, the slope of my tangent, f prime of c. And the points x1 and y1, what they're actually going to be equal to is c comma f of c. You see that? And so when I plug that in, y minus f of c equals f prime of c times x minus c, it's like, oh my gosh, it is the first order Taylor approximation. Right? Because there's the slope of your tangent and the coordinates of your point are c comma f of c. So that's all. That's all I need to tell you on tonight's homework. Whenever they ask you get the linearization, now you'll just get the first order Taylor approximation and you'll be fine. They mean the same thing. Okay, well, hey, that's it. Any other questions or issues? Okay, then I will look at the camera and say bye-bye.